Hi, today we're solving Leetcode number 101, symmetric tree. Given the root of a binary tree, check whether it's a mirror of itself, i.e. symmetric around its center. Yes, so as you can see in the example, if you divide it from the middle, the one is the root. I'm gonna use this sketch on the right to illustrate basically the same thing. And if you go to the left, it's 2, and the right side is also 2, which makes it symmetric. Similar thing. So as you can see in the example, the input is 1, which is the root, and then 2, left node, right node, and then the extension of the node, the left node of 2 is 3, and right node is 4. Similar thing goes here and here. So let's give a little bit example or sort of walk through this tree node structure. So as you can see, especially I think it's better, more understandable from this part where the 4s are the same and the 3s are the same. So we construct our tree node from the root to the left to the right. So this 4 should be, if you start from the root, the left, and then it's the right of the left. And this 4 is if you go from here to the right and then to the left. So as long as this 2 are the same value, then they're symmetric. Similar thing with this 2. So this one would be the left of the left, and this 3 would be the right of the right. Just by their position, as you can see from here. And if you can go like further down, which would be just the same, because all you want is to make sure the left side and right side are equal. So what's our ending condition? Well, if we evaluate each node starting from the top and to its left, to its right, to its left, to its right, and until here, if you still try to go left and right and there's no more nodes there, I think this is where our program should terminate. So in each node you need to check, first of all, of course, the node itself has to exist, and then look over the shoulder to its left, to its right. And there are 2 ways of solving this problem. One is iterative way, and the other one is a recursive way. Let's try to solve this in the recursive way first. And I'll have another video about the iterative way. If you feel like this looks a little bit confusing, the code is gonna be much easier to understand. So I guess let's dive right into the code. So let's construct the node first. We're gonna have a class of tree node, and inside of it, we're gonna construct the root node, and the default value would be 0. and then the left default value is none, and right same, none, just to initialize the self.bar equals far and self.left equals left. Similar thing with the right equals to right. And then it's our solution class. We need a function, let's call it is symmetric, and there's gonna be one argument, the root, and inside of it we're gonna recursively call this function. So let's just call this function recur. And what this function does is that it, like I said before, it goes to the left and right side of each node. So we need to pass in left and right. And we always start from our base cases where the program is going to terminate. So it starts from, if you still remember, let's say at the end of here, if you go to the left shoulder or the right shoulder, there's nothing there, then it's over. And also there's another case where if you have one, let's see, you have a number 5 here, but then there's nothing on the right side. So this is obviously a false value because it's not symmetric. There's no right branch to this one. But if you have another one and they're not equal, then this boolean also is false. So what you want is symmetric, like this one with 4, or like this one with 2 and 2. Left equals to right, or the left and then go to right equals to right equals right to the left, or a similar way, this left and left, right and right. That's how you call symmetric. So let's go back here and get our base case first. First, you want to make sure the terminating case. So if the left equals to none and the right equals to none, so there's nothing left, then it's true, because if they're equally none, then I guess they're symmetric. And otherwise, if left is none or right is none, so only one side has value, then obviously you need to return false. And the other scenario is if left value does not equal to right value, then you need to return false. But other than that, we just want this recursive call to recursively call itself to its recursively to its left of the left and right of the right, and also to compare the right of the left and the left of the right. So return recur so you need the left as the left argument and right as the right argument. You wanted this to be called recursively, and you want the right, well, it doesn't really matter, but I think it's a little bit more understandable if I put left. Remember, left the right and then right the left, to evaluate if both of these conditions are true. And the last thing we need to do is just to call this function. We pass in our root inside of here as left and then as right. So, and then it's gonna start from the top one and then going to both sides recursively. Okay, let's test if this one works. So get an instance of this class solution. And we need, let's see, a value of 3. We can just construct like this first 3 first. So an instance would be for this one. Let's call it number 3, number 2, number 1. So number 3 is gonna be has the value 2 and then none to its left, none to its right. But you don't really have to put none there because the default value is none. So for the second one, I could just put 2. But for the root, the very top one, you need to put 1, and then to its left is 2, and to its right is 3. Okay. Now we just need to print out our result, which is put into this function is symmetric and put our first value in there as the root, and then print rest. Let's go to the command line. Okay, yeah, I think I'll just start Python 3. I think I name it, actually, I don't remember what's the name, Q draft py, and it says none, okay, where it's supposed to return true or false. Let's see. Return, I think, should we put like parenthesis around this? Oh, sorry. Because this needs to put return. You need a return value. It's a Boolean value. So yeah, let's try it again. Yeah, that's correct. It's true. So if I change this 2 to 3, so it's like 1, 2, 3, it's not supposed to be symmetric, so we're expecting false. Let's run this again, and there you have it. So it's false. Just a quick recap. In this trade node, the value and then to the left and right, first we define all the base cases where you run out of nodes, then you return true. Otherwise, if there's just one side has the value, then it's false for sure. Or if the values don't equal, then it's also false. Otherwise, just keep going to left of left, right of right, and then evaluate the two sides, and also going to the right of the left and the right of the left. Yeah, it's a little bit more easier if you see it visually, like this 2 4s and this 2 3s. And I hope this makes sense, and I hope this is helpful. Thanks for watching, and see you in another one.